Okay, so previously we've been asked to find a probability or percent of a normal value, and we were either given a given of a normal curve, and we were either given a z-score or an actual value, and we used norm CDF when we did that. Well, we're going to introduce today something called inverse norm, and inverse norm actually works backwards. In other words, if they give you a percent, can we find a z-score? Now, students get confused with this. They go, hey, I'm not sure which one to use when. So I want you to remember APPS, APP, area, percent, probability. So if they ask for the app, if they ask for the area, the percent, or the probability, use normal CDF. If they give you the app, if they give you an area, a percent, or probability, use inverse norm. So in other words, once again, if they ask for this, you're going to use normal CDF. And if they give you APP, use inverse norm. I'd go ahead and star this. This is like a really important hint for you guys, but I think it'll help you out a lot. Okay, so we're going to understand that the underlying population is normal for the following examples. And this is really important because we can only do inverse norm and normal CDF if we're working with normals. So a student claims to have scored at the 99th percentile. What is the associated z-score? So the student claimed to scored at the 99th percentile. Well, please remember, percentile ranks start at 0 or negative infinity. So since we're working with a continuous distribution, we're starting at negative infinity and going on. It's going to be one of these two, but if we're working with a normal, we don't have to worry about this. We'll be always at negative infinity. Percentile ranks always start from the left and they move to the right. So please don't forget that percentile ranks always start at the left and move to the right. So I'm going to go ahead and start by drawing my picture. And we want a z-score, and please don't forget this, once again, super important. The mean is 0, the standard deviation is 1 for all z-scores. So we know our mean right here is at 0. Well, halfway is 50%. We're at 99%, so we're going all the way, shading all the way up. And this right here, this area, or this probability, or this percent is 0.99. And what we're looking for is that z-score. Please don't forget, this is going from negative infinity, and this goes to positive infinity. The great thing about this is there's not a whole lot more to have to do on this problem. So this is going to be an inverse norm. And it's going to ask, the very first thing the calculator will ask for is the area, then it's going to ask for the mean, then it's going to ask for the standard deviation. So real quickly, let's take a look at this. Second vars, inverse norm, and we're looking at mean, standard area, mean, standard deviation. So our area in this case is 0.99. Then our mean is 0 because it's a z-score, and all z-scores have that, and then a standard deviation of 1. That's about all we have to do, except now, so area is 0.99, mean is 0, standard deviation 1, and like I said, that's about all we have to do. And we end up getting 2.3263, and that's our answer. And we're done. So that takes care of our first one. The next one, a student claimed to have scored at the 25th percentile. So once again, we're dealing with a percentile rank, so we know we're going to start at negative infinity, etc. It says, what is the associated z-score? All z-scores, mean is 0, standard deviation of 1. Drawing our picture, we're centered at 0. We're going from negative infinity to positive infinity. Percentile ranks work from left to right. Well, this is the halfway point, but we only want 25%, so we're definitely less than halfway. and this little area right here is 0.25. So notice I've been using the term area and percent interchangeably, and they are. This probability is 0.25, this area is 0.25, this percent is 0.25. So once again, we're going to do a second vars inverse norm as it shows up above. Second vars, number 3, inverse norm. And so I'm going to write that down, inverse norm. This is your work shown. My area is 0.25. My mean is 0. My standard deviation is 1. So second vars, inverse norm, 0.25, mean is 0, standard deviation is 1, and we get negative 0.6744. Now, does it make sense for this to be negative? Well, remember, this is essentially a number line from negative infinity to positive infinity, and since we're below 0, it's like, oh yeah, if it's less than 0, it's got to be negative. Now we're going to start to get a little crazy tricky. It says the upper 10% of scores students are associated with what z-score? And I'm going to go ahead and draw the graph. I'm not going to do any shading at this point, because I will tell you the problems like this are a little trickier. The calculator part's just as easy, but the problem is more difficult. So anytime they give you a direction, with the percentile rank, you can just go, because they all percentile ranks work from left to right. But if they say the upper or the lower, etc., I always want you to put an X. Just draw an X on a sheet of paper. You're like, why? Well, here's why. This says the upper 10%. So upper means we're above. All right, upper means we're above. So that means this upper section right here is 0.10, and this is the z-score I'm looking for. Now, the reason this is tricky is because the calculator is working from left to right. So the calculator all works from left to right, so it's going to give you this area right here. If I put in 10%, I'm going to get a negative z-score. Well, clearly we're above 0, so we need a positive z-score. So that means I need to work with 1 minus 0.10, which in this case is 0.90. So inverse norm, my area is 0.90, or 1 minus the 0.1. It's a z-score still, so our mean is still 0, our standard deviation is still 1. Second vars, inverse norm, 0.9, mean is 0, standard deviation 1, and it's like 1.28. Well, that makes sense. 1.2815, that sort of makes sense because it's positive, which means it's above 0. All right, because it's above 0, so we knew it had to be positive because the whole thing had to be of 0. The next one also has a direction. It says the low is 10%. All right, so we have an X. Well, this is low, so that means it's below the X value. So that means I'm actually going to be shading below. So this right here is 0. And as long as we have is shaded to negative infinity, we're good to go. We don't have to do any of the subtraction that we did right there. So this is 0.10. We have an inverse norm. Hey, we shaded to negative infinity, and that's kind of the key. Did we shade to negative infinity? Up here we didn't, so we had to do the 1 minus. Here I did, so I don't have to do the 1 minus. This is 0.10. It's a z-score, so mean is 0, standard deviation of 1. So here we go. Once again, second vars, inverse norm, 0.1, mean is 0, and we end up getting negative 1.28. And that, you're like, well, wait a second. Why? Why did we just get a swap? We got the switch because we have in the tail 10% going this way and 10% going this way. And don't forget that the normal curve is symmetric. All right, 80% of the students scored above what? This is not a percentile rank. It doesn't say percentile. Remember, percentiles go to negative infinity. This doesn't say that, so we're not sure. So consequently, I need to draw my X. All right, I draw my X, and it says 80% scored above what? 80% scored above X. This is 0.80. It's on the high side because it's above. So consequently, I do this. Mean is 0. And I'm starting from positive infinity. I wanted to start at negative, but it says above. So anytime I'm coming from above, I'm coming this way. And this is 50%, so I have to cross over. And this is 0.80. So I'm looking for this z-score. Well, the z-score I'm looking for better be negative. All right? Now, the problem is, once again, I did not shade from negative infinity, and that's the way the calculator works. The calculator works from negative infinity, so this needs to be 0.20 because it's 1 minus the 0.8. All right? So, inverse norm, 0.2001. So let's do that real quickly. And the reason it's 0,1 is because it is a z-score. So second vars, inverse norm. The area is 0.2. The mean is 0. The standard deviation is 1. And we calculate it, and we get a negative z equals negative 0.8416. And it would make sense that our z-score was negative because it's below 0. All right? Since we're below 0, it's negative. All right. Just hold on for just a moment. I'm going to pause this for just a second. All right. So we were doing previously, well, in the first part of this video, we were working with z-scores. Well, last time I knew, I really didn't go around talking about z-scores. Hey, what's your z-score? It was a great pickup line. Said no one ever. So we generally like to talk about actual values. Z-scores is what's going on behind the scenes. They have a part in statistics that you're going to see a lot of in about 2 weeks. We're going to actually bring all of this together. But for right now, we're going to separate z-score problems from actual value problems. Once again, students get confused. When do I use normal CDF? When do I use inverse norm? Really great question. Don't forget the apps. If they ask for an area, percent, or probability, use normal CDF. If they give you the area, percent, or probability, use inverse norm. Once again, these problems, they're going to give you the area, percent, or probability. So we're going to be using inverse norm. So for the following questions, assume the population is normal, and it's really important. If we're going to be using something that says normal or normal, it better be normal. So we're starting off with a normal, and we have a mean of 79 and a standard deviation of 7. Notice that's different than the z-score. When we had a z-score, we're working with z-scores, all z-scores, all of them, mean equals 0, standard deviation is 1 if we're working with a z-score, but we're not. We're working with actual values, and we happen to have a mean of 79 and standard deviation of 7. So a student claimed to have scored at the 99th percentile. Well, percentiles always start with negative infinity, so that makes my life a little bit easier. I'm not going to have to do any of the subtraction work. So my mean is 79, and negative infinity to positive infinity. And so since it's a percentile, it starts at negative infinity. So we're just looking for this shaded area, which is 0.99, and this z, and not z-score, we're looking for this x value. We're actually looking for an x value this time, not a z-score. So we're going to use the same calculator function, which is second var's inverse norm. So inverse norm. We know that the area is going to be 0.99. And now we're plugging in the actual value z-score, which is going to be 79 for the mean and 7 for the standard deviation. So second var's inverse norm, area is 0.79, area 0.99, mean of 79, standard deviation of 7. And what we find out is that student's X value actually scored at the 95.2844. Now I recognize that probably is probably 95 that they scored, but basically they scored a 95 on the test, and the average score in the class was a 79 with a standard deviation of 7. Another student claimed to have scored at the 25th percentile. What is a z-score? Once again, percentiles start at negative infinity. So we're here at negative infinity. We have a percentile. We have a mean of 79 still. 25% is less than halfway, because remember 79 is at halfway. So we're looking at 0.25. Because percentiles start at negative infinity, we don't have to worry about any subtraction. They've told us our mean is 79 and our standard deviation is 7. So we can start plugging in what we know. We know we're working with an inverse norm because they gave me the app. They gave me a percentile, so they gave me an app. So since they gave me an app, I'm working with the inverse norm, so 0.25, mean of 79, standard deviation of 7. So second var's inverse norm, area 0.25, 79 was my mean, my standard deviation is 7. So we end up saying, you know what, this student probably made a 74 on this test. But we're going to go ahead and take it out to 4 decimal places in front. All right. The upper 10% of students are associated with scores above what? Here, once again, they did not tell me that it was a percentile rank. They did give me a percent. So they gave me a percent, which tells me that they gave me the app. That means I'm working with an inverse norm, but they said they didn't give me a percentile rank. So I need to use my little X trick. So I put my X, and it's like, oh, 10%, the upper 10%. So this means this is on the upper side. So when I'm drawing this, there's my mean at 79. I have a negative infinity, a positive infinity. This is the upper 10%. So this is up here at 0.10, and I'm looking for an X value that's above 79. All right, because it's the upper 10%. Remember, 0.1 is above. Now, here's the tricky part. Once again, the calculator works from negative infinity to this value. So I need to find this area right here. This is what I need right here. So that means I need to do the 1 minus 0.10. So I'm looking for 0.90. So the upper 10% is really associated with the 90th percentile. So this is going to be an inverse norm of 0.90, because we always have to start from negative infinity. 79 and 7, because that's our mean and standard deviation. And remember, it's an inverse norm because they gave us a percent. So we're going to use 0.9 and calculate, which is going to be 87.9708. So basically about an 88. All right. Here they say the lowest percent. Once again, they did not tell me it was a percentile rank. Since they didn't tell me it was a percentile rank, I put an X, and it's like, oh, this is on the low side, so it's down here. So it started at negative infinity. All right? Really important to know whether we're starting at negative infinity or positive infinity. So this is at 79, negative infinity, positive infinity. And this is 0.10. Well, hey, since we started at negative infinity, we started at the left, we're good to go with the inverse norm. And remember, we get to use inverse norm because they gave you a percent, they gave you one of the apps. So inverse norm, 0.10, 79, and 7. Obviously, this X is less than 79, so we better have a X, we better end up with a number that's smaller than 79. So that person that scored in the lower 10% scored a 70 or lower, all right? Equals 70.0291. I know I took that off the screen really fast, but that's where that came from. Okay, the next thing, 80% of the students scored above what? They didn't, once again, they did not tell me this was a percentile rank. So I put an X. And they said, oh, this X is above, so it's 0.80. So that means I'm starting at positive infinity. So that means when I'm shading from positive infinity. So this is 79. We're shading from positive infinity and coming down. Well, 80% is over halfway. So somewhere over here, this represents 0.80. And so I'm looking for that X value right there. Now, please remember, the calculator works from negative infinity up. So we are going to have to subtract. Okay, anytime we're shading from above, we're going to have to subtract. So we're going to have 1 minus 0.80. And that tells me that this part that I'm shading right now is 20%. All right. So in this case, we have an inverse norm, lower 20%, which is 0.20. My mean is 79, and my standard deviation is 7. And one other thing to keep in mind, we know that this value, this X, whatever they scored, it's lower than 79. So when we're done, we better end up with a value that's lower than 79. So the second bar's inverse norm, area in this case is 0.20. And we end up getting about a 73. So about 80% of the class, or 80% of the class, scored above a 73. And that's what that means. So please remember the apps. If they give you an area, a percent, or probability, if they give you the area, percent, or probability, use inverse norm. All right, in all of these cases, they gave me an area or a percent. All right, the next video will be on actual scenarios as opposed to just some values.